Hey everybody, this is Mr. W. Our topic today is called factoring. By the end of this video, you will be able to identify and list all factors for a given whole number up to 50. List all factors of 12. Well, I know that factors are numbers when we multiply. So for example, 1 times 12 is equal to 12. Our factors would be the 1 and the 12. But I can also equal 12 if I multiply 2 times 6. So 2 and 6 are also factors. Remember, we're listing all factors. And I can do it a third way. 3 times 4 would also equal 12. And those are all the factors. So if it says to list all factors, I'm going to do that right here. Our factors would be, I'm going to put them in order. 1, 2, 3, 4, 6, and 12. And the idea here is that if I were to say, well, 1 times 12 equals 12, 2 times 6 would be equal to 12, and of course 3 times 4. This is what we mean when we say to list all the factors 12. So that's what we're doing today. Remember that factors are the numbers that we are multiplying. For example, 2 and 6 are the factors for this equation. 12 would not be a factor. 12 would be called the product. One of our key ideas today is that many products or many whole numbers have more than just two factors. And here's just a real quick rundown of the first, numbers from 1 to 12, right? Only two factors, 2, 3, 5, 7, 11, and 13. Those are numbers that have only two factors. More than 2, 4, 6, 8, 9, 10. We'll go into that in more detail, but just understand that some numbers have only two factors, and some numbers have more than two factors. Let's do some easy problems. List all the factors of the following numbers. So we'll start with some nice easy ones. 3. Well, 1 times 3 is equal to 3. And this is the only way that I can equal 3. For example, I can't go 2 times 2 or 2 times 5. Our only way to get 3 would be equal to 3. Now, some people may say, well, can you switch it with the commutative property? And the answer to that question is yes, but notice that we still have 1 and we still have 3, so we don't need to list that. I'm just going to list our factors of 3 right over here, 1 and 3. 4 is also a pretty easy one. 1 times 4 is equal to 4, but we could also say that 2 times 2 is equal to 4, and there are no other ways to get to 4. So I'm going to list my factors. Remember, we want to list them in order of value from left to right. So I'm going to say 1, 2, Notice that I have the 2 twice. I do not have to list that 2 times. So I'm now just going to put the 4. So our factors of 4, or all the factors, remember we're looking at all the factors of a number. All the factors would be 1, 2, and 4. 6, 1 times 6 is equal to 6. And 2 times 3 would also be equal to 6. So if I list them, I would write them as 1, 2, 3, and 6. And remember that I would like to write them in order. Let's try ones that are, we'll call them medium, okay? So I'll just draw it's a medium face. I guess that's a medium face. Notice the idea of the number line. You don't have to make a number line, but I'm put this here just to illustrate the idea. So our first would be 1 times 10, and I'm showing that here. So when you do these, especially problems are a little bit harder, think of it as a number line. Any other factor of 10 is going to have to be these numbers here in between. So the next number to check would be 2. And yes, that is a factor, 2 times 5. And I said 5, so we've eliminated all of these others. And then the only ones left to try would be 3 and 4. And 3 times anything does not equal 10, and the same thing with 4. So when we list our factors for 10, we would list them in the same way: 1, 2, 5, 10. Let's try 12. Again, think of it as a number line. 1 times 12. Next, I would check 2. And yes, 2 times 6 would also equal 12. I've eliminated all of these. It's impossible for anything. For example, I wouldn't say, well, 7 times 1. No, that would equal 7. Or 7 times 2, or 7. Nothing up here is going to equal 12. But we can check down here. Yes, 3 is a factor. In fact, if I go 3 times 4, that would equal 12. Notice that in between 3 and 4, there are no more numbers, so we can stop here. So our factors of 12, I think we did this on the other page, by the way, of course. 3, 4, 6, 12. Let's try 18. Notice this time I'm just drawing a partial number line. You don't have to make a complete number line, but this does help you to organize your work. Our first is going to be 1 times 18. The next naturally would just be to check 2. Well, 18 is an even number, so yes, it is going to be 2. And my knowledge of multiplication, or just using a multiplication table, I know that 2 times 9 is equal to 18. So then I would have 9. Now the numbers next would be 3. And I know from my knowledge of multiplication that 3 times 6 is equal 18. So let's see, 3 and 6. Now remember, the only numbers in between 3 and 6 would be 4 and 5. And I know that 4 times any number or 5 times any number will not equal 18. So here are all my factors of 18. I'm going to list them in order: 1, 2, 3, 6, 9, and 18. Like a lot of things in math, there are some rules, rules of divisibility, or sometimes they call them rules of testing for testing for divisibility. That has to do with the idea of inverse, for example, if we're doing factors and someone would think, well, aren't factors have to do with multiplication? And the answer is yes, but remember that multiplication and divisibility or division are inverse, so it's a related. So we can just refer to them as some rules, right? Um, think of the one rule. That's called the identity property of multiplication, meaning that every single whole number has a factor of 1. So when you're asked to do factors, did you notice that on this list here, and the ones that we've done so far, that every single list we see 1, 1, 1, and the number itself, 18, 18, 12, 12, 10, 10. So that's what we mean by the identity property. I'm just going to call it the one rule, that every number, it's a great place to start when you're doing this, has a factor of 1. Then the next rule would be even numbers. Always check 2 after you do your 1. Always check 2. And 2 will always be there if your number is even. So for example, if I have the number 9, well, 9 is an odd number. Therefore, it's impossible for it to have a factor of 2. But let's just say if I say, well, it's going to be 22. I know that 22 is an even number. So when I'm doing my factoring, I know it will have a factor of 2. And he said, well, 2 times what? That'll be our job to figure out in the next page or two. But at least you know that it's divisible by 2. The next rule would be odd numbers. Remember that odd numbers end in 1, 3, 5, 7, and 9. If you have an odd number that you're evaluating, it will not have any even factors. The fourth is called the 3 rule. And this is kind of a cool one. It's yes, it's divisible by 3 if the digits are divisible by 3. Let me show you what I mean. And by the way, you can have remainders here. For example, 12, I could just tell you is going to be divisible by 3 because if I take the 1, out like that, which is right here, and the 2, and I add that, I get 3. And you can see if I take 3 and divide it by 3, I get 1. Remember, you cannot have remainders to make this work. 39, is it divisible by 3? Well, I can add 3 plus 9 and get 12. Well, I know that 12 divided by 3 would be 4 and no remainder, so yes. Now, in this case, 35 is not divisible by 3. So, well, how do you know? 3 plus 5 is equal to 8. If I take 8 and divide that by 3, what I'll get is something like a 2 with a remainder of 2. But you may not have remainders. So in this case, that would not be. So that's a neat little rule for 3. I call it the 3 rule, that if you add your digits and if they're divisible by 3, it means it has a factor of 3. And then quickly, 5, if a number ends with 5 or 0, 5 will be a factor. For example, 10 ends with a 0, so it will have a factor of 2. In fact, that would be 2 times 5. Or think of, say, 15. A 15 ends with a 5, and it will have a factor of 5. Excuse me. And then finally, multiplication chart is a great way to help with factors. For example, let's just say if you're doing 54 and you're having a hard time, I could check my different factors here and see that, for example, under 6, it's 54, 6 times 9. So a multiplication table and your knowledge, I wrote here the note, always memorize your facts. But for now, if you need to use your multiplication table, that would be fine. Let's do some that are a little bit more challenging. Find all the factors of 36. Remember our idea of the number line, 1 and 36. So I know that to find factors of 36, that 1 times 36 would be factors. 36 is an even number, so I know that there's going to be a factor of 2. Well, 2 times what? Well, if I take 36 and divide that by 2 using our, remember we on a previous video, the DMSB method, 2 goes into 3 one time. We multiply, bring down the 6. 2 goes into 16 18 times. So 2 times 18. How about 3? Well, we said that we can add 3. Do that over here. Let's see. 3 plus 6 is equal to 9. Is 9 divisible by 3? And the answer to that is yes. It goes 3 times. So 3 times, and this is where your multiplication chart will come in handy. I believe that if you go to your 12s, you know that 12 times 3 is equal to 36. So 3 times 12. All right, let me see where we're at right now. We have 1, 2, 3. We said we had 18, and then we just have 12. So everything in between now is the only ones we can check. So let's check 4. Well, I know that 4 times 9 is also equal to 36. And again, this is where your knowledge of your multiplication tables, 4 times 9 is 36. The only numbers I have left would be 5, and 36 does not end with a 5, so it can't be 5. How about 6? Yes. So I would say 6 times 6, and I'll show that to you on a chart. 6 times 1, 2, 3, 4, 5, 6 is equal to 36. And then that would be the last one. So if I list all my factors, and there's quite a few, remember we said that this was a more challenging example, that would be 1, 2, 3, 4, putting these in order here, 6, I'm not going to list my 6 2 times, just one time, 9, 12, 18, and 36. So our factors would be right there. I know this video is going a little bit long, and if you're getting the idea, that's fine. I'm going to do a few more. You're free to turn it off if you want, but if you're still struggling with some of these longer ones, let's practice a little bit more. All factors of 42. I'm going to start here with 1 and 42. That's just to visualize. So I know that 1 times 42, because of the identity property, I know that 2 is an even number. So 2 is a factor for sure, but 2 times what? Again, my knowledge of dividing using the divide, multiply, subtract, and bring down. 42 divided by 2. 2 goes into 4 2 times, right? 2 times 2 is 4. We bring down the 2. 2 goes into 2 one time, so it would be 21. So 2 times 21. How about 3? Remember we said if 4 plus, we take the 4 plus 2, well, that would equal 6. And guess what? 6 is divisible by 3. It goes in 2 times. So now we're not putting 6. We're just saying that the 4 and the 2 were equal to 6, and 6 is divisible by 3 if we use the 3 rule. So 3 times what is equal to 42? Well, I can use my knowledge of division. 3 goes into 4 one time. If I go 1 times 3, 3 goes into 12 a total of 4 times. So that would be 14. 4 would 4 go into, well, I can check here. Remember we said you can then use your multiplication table. I'm not seeing 42, so we can eliminate 4. 5 will not go into 42. Remember we said to be 5, it has to end in a 5 or a 0. How about 6? Yes, 6 would go 7 times. So 6 times 7 would equal 42. So if I were to list our factors for 42, it would be 1, 2, 3, 6, and remember they should be in order, 7, 14, 21, and 42. These would be all of the factors for 42. Let's do one more. Find all of the factors of 45. Well, we know the identity property or the 1 rule is going to be 1 times 45. 5 is an odd number, so it's not going to be 2. Let's try 3. Remember, if we add 4 plus 5, I'm going to show that over here, 4 plus 5 is equal to 9. And we said previously that 9 is divisible by 3, so it is a factor. 3 times what? We can use our understanding of division. 3 goes into 4 one time. 1 times 3. If you subtract and bring down, 3 goes into 15 5 times. So 3 times 15. 4, I think now we can use our chart, and I do not see 45. But 5 for sure, because it ends in a 5. I see it right here. That's going to be 5 times 9. That would leave us with 6, 7, and 8. And if you look, I do not see 45 for 6. I do not see 45 for 7. I do not see for 8. So our factors for 45 are going to be 1, 3, 5, 9, 15, and 45. All right, so again, everybody, thank you for hanging in there. If you actually did hang in there this long, I would imagine most of you probably turned it off a while ago. But if you actually did, good for you. Our lesson is on factoring. Factoring has to do with finding the factors of a number that is given to you. And today we did not go above 50. And we have to list all of the factors. There are strategies that we discussed called the rules of divisibility. And you write the numbers in order from left to right in the order of their value. We said that there's rules for the 1 rule, for even numbers, for odd numbers. If you were to, if it's an odd number, it cannot have an even factor. The 3 rule is when you add the digits. The 5 rule is that if a number ends in 5 or 0, it always has factors of 5. And finally, your multiplication chart. Okay, gave you a lot of things to think about today. I appreciate your hard work, and we'll see you next time.